Yeah, good morning children. Today I am going to do an experiment from class 12. The experiment is to find resistance of a given wire or standard resistor using meter bridge. Okay. The apparatus required in this experiment are meter bridge. Look at the apparatus. Yeah, this is the meter bridge. It has a wire of 1 meter length. We have this is the resistance wire. We have taken a 1 meter length. This is a power source, battery eliminator, which is of various voltage, and we will use 2 volt. This is a resistance box. This is the galvanometer, and we have a jockey. So these are the apparatus required. What are the apparatus? The meter bridge, the galvanometer, the resistance box, the battery eliminator, the jockey, and the resistance. Okay. Now, what is the principle? The principle of meter bridge is it works on the principle of balanced Wheatstone bridge. So we know that what is a balanced Wheatstone bridge? That the 4 arms are there, P, Q, R, S. So the working principle is P by Q equals to R by S. Okay. Now let's see the apparatus. Now again you can have a look on the apparatus. Yeah, this is the meter bridge. Here you can see there is a wire of 1 meter length. This is a complete 1 meter length. Yeah, this is a meter bridge. This gap we will connect a known resistance, and here we connect the unknown resistance, this part. So this is the resistance wire. We have taken it of 1 meter length, and it is unknown. We don't know the resistance of this wire. The resistance box, this is your known resistance. The resistance box, here you can see the different resistance values have been given. So whenever we take out the NET, that resistance will come into the picture. So if I take out 5, then it is 5, and if I take again 10, then it becomes 10 plus 5, 15. So this way we can have a various combination of resistance. This is our known resistance. So we are going to connect it to the left gap, this part, and here the unknown resistance we are connecting it in the right hand gap. Now we will use a battery eliminator of a source of 2 volt. It should not be more than 2 volt. This is the precaution area. And then the positive end of the battery eliminator, that is plus, this one, the red one. The negative is the black one. So the end where we will connect the wire from the positive, that is the plus, that will be taken as 0 on this scale. So we find there are, you can see here, the 2 datas are there. You can see here there are the 2 datas over here. It's 0 and 100. So if I connect the positive terminal over here, then the reading will start from 0. Right. So now let's connect it here. So again let's see here. So this resistance wire, this is the meter bridge wire of 1 meter length. The unknown resistance is this one, which has been connected in the right gap. The left gap we have the known resistance. Now we will connect the galvanometer at this point. There is a screw in between these 2 gaps. The galvanometer will be connected with a jockey. So one wire will be connected to the red part, that is positive, and the black is connected to the jockey. And then when we touch this wire, then what will happen? You will find the null point. What is the null point? Where there is no deflection in the galvanometer. That is the balance point. So by getting a balance point, what we are going to do? We will get, so you can see now it will become like a Wheatstone bridge. So this, the known resistance is your P, the unknown resistance is your Q, the first length from 0 to this jockey, that will be R, and from the jockey to the another end, that will be your S. So we get the 4 resistances over there. The principle of balanced bridge is P by Q equals to R by S. So here P is your resistance box, Q is your unknown resistance wire, L1 that is the 0 to the jockey, that is your R, and from jockey to the that is the S. Okay. So children, again I am repeating what we are doing today. You can see here what is the aim of the experiment, what we are doing, what are the apparatus required. What is the principle? It works on the principle of balanced Bridgestone bridge, that is P by Q equals to R by S. Okay. Now let's see the circuit, how I have done the circuit connection. Okay. Now let's have a look of this. Yeah. This is the power source, and we have given a 2 volt. It should not be more than 2 volt. This is the first condition, right? And this is the resistance box. It has been connected in the left cap, this one. Okay. Now when we will take out any resistance from the resistance box, that will be taken into account. Now suppose that I have taken 2 ohm right now. Can you see that? I have taken 2 ohm from here, so the 2 ohm will be taken into account. But the precaution is, suppose that this is loose and you are just finding it in this way, then this is also there in the calculation. So it all should be pressed hard. They should not be loose, otherwise they will be also there in the cell. So you will have to take precaution over here when you connect. Now the battery eliminator, the positive terminal I have connected on the left end. So my calculation will, 0 will be from here and the 100 will be on the right hand side. Okay. The battery eliminator should not be more than 2 volt. And I have connected the unknown resistance in the right gap. So this is the jockey. The jockey has been connected to the galvanometer, and when the needle of the galvanometer will be at 0, then that is called null deflection, that is the balance point. We are going to detect that point. The jockey should not be dragged, it should be touched at different points. This is another precaution. You should not drag it. The wire should be uniform, otherwise your calculation will become wrong. Okay. Now when, again I am repeating, the known resistance is connected in the left cap, the unknown resistance has been connected in the right cap, and the jockey is connected to the galvanometer. Okay. Before you start the experiment, we will have to check whether your connection is correct or wrong. How you will get it to know? So as soon as you will switch on, okay, and the potential applied should not be more than 2 volt. This is the precaution. Now what? Let's see whether the connection that we have done is correct or wrong. I am switching it on. Now you can see here in the galvanometer that when I will touch the jockey on the left end, you can see the deflection of the needle in the galvanometer. Now when I will touch it on the right hand side, on the another side, the deflection should be opposite. Then only then the connection is correct, otherwise the connection is not. So you can see the deflection is opposite, that means our connection is correct. Now I can start the experiment. If you are not getting deflection in the 2 opposite directions, then your connection is somewhere off. So before you start the experiment, you please check by touching the 2 ends with the jockey. Okay. So we know that what is the working principle? The principle is the balanced Bridgestone bridge. What is the working principle of the balanced Bridgestone bridge? That is P by Q equals to R by S. So in this case, try to understand. In the case of P means you're the first one. This is my resistance box. I am calling it as R. Resistance RB is my R. The unknown resistance is X, and the length from the left end to the jockey end, where I will get a null deflection point over here. Just see out here, I have taken 2 ohm. Now I can show you where will be the deflection on the left end. This is the point of the null deflection. Can you see this? Now the length from one end, from the left end to the jockey, will be known as balancing length L, and the wrist length will be 100 minus L. Okay, so there will be two lengths, one will be L balancing length and the another will be 100 minus L. So please note down the working formula will be, that is, you can see the P by Q equals to R by S. So P is replaced by the resistance box R. So resistance box, the known resistance is R, the unknown is X, the balancing length is L, and the rest is 100 minus L. So how to get X? Therefore X equals to R into 100 minus L divided by L. So this is the formula we are going to use. How to get the resistance? The unknown resistance X equals to R into 100 minus L by L. What is R? The known resistance that we are taking out from the resistance box. Okay? Ready? Then we make a table like this. The first is number of observations, 5. The second column is known resistance, that is RB. What is RB? Resistance box. So we will take out five times. Any combination you can take. The choice is yours. So you will take out any 5 resistance from here. That will be known resistance. And then we will find the balancing length. What is the balancing length? The length from 0, from the left hand 0 to the jockey is known as the balancing length L, and the rest is termed as 100 minus L. So we will note down L, we will note down 100 minus L. So what is the working formula? The working formula is X equals to R into 100 minus L by L. So we will calculate X for 5 times. Because we are taking 5 observations, then we will take out the average. Okay? So today we are going to perform how to calculate the resistance of an unknown resistance, that is the standard resistor, using a meter bridge. Okay? Here. So I am taking out the first reading. The resistance taken out from the resistance box is 2 ohm. So my known resistance is 2 ohm. Okay. So the first reading is for 2 ohm. Right. Now let us find out the balancing length. So I am going to switch on the power source. Now you can see here, I will have to check whether the connection is correct. So it goes on the left hand side, the another end goes on the right hand side. The connection is correct. Now I am going to find out the point where there is no deflection, that is the needle point at 0. Now you can see there is a no deflection in the galvanometer, and the reading is, now which reading I will have to take? You can see the scale. So there are 2 readings out here. One is 36, another is 64. So I will have to take 64 because my 0 is on the left hand side. So balancing length is L is my 64, and 100 minus L will be 34. Okay, so I am going to 36, 64 and 36. Now I am taking the second reading. Can you see? I have taken out 1 ohm from here and 2 ohm from here. So now my known resistance R will be 3 ohm. So I will note down here 3 ohm, and I will have to find out the balancing length. Again I will touch on the left hand side to check whether anything went wrong. No, it's correct. Again I will have to find out the balancing length. So I can find. Yeah. Can you see? So the reading is 59 and 41. Okay. Yeah, while noting down the reading, you will have to switch off the power source because otherwise the wire will become hot. That is also one of the precautions in this experiment. So you should not leave the power source on for a long time. Now again you can see what is the resistance I have taken out, 2 plus 2, 4 ohm. So the known resistance I am taking R is your 4. Again I will have to find the balancing length. So let us find out the balancing length, that is the null point. It is around 68.5. Yeah. 68.5 and 31.5. Now this reading I am taking it for 5 ohm. You can see only one resistance has been taken out, that is 5, and the galvanometer shows no deflection, right? Right. And the reading again the same, that is my 69 and 31. So I am noting down for 5 ohm. Can you see the resistance box? What is the resistance I have taken out? See, this is 0.5 and I am taking out 1. So the total is 1.5. So the known resistance is 1.5. I am finding out the balancing length. Again I will switch on the source and I will check. Yeah. So let us find out. It is 40.5. You can take 41 and 59. 41, 59. Let's check the last reading. Please participate. What is the resistance from here? 0.5. What is this? 2. What is the total resistance? 2.5. So I am taking out the resistance box, known resistance 2.5. Let us check the balance there. Null point. It is 51, 49. 51, 49. Okay. Yeah. Student, please, again I am repeating it. I told you while doing experiment, if anything is loose, then that will be taken into account and your reading will come incorrect. So I am again rechecking my data, whatever I have taken. So again I am repeating it. You can look into the resistance box. What is the resistance taken out from the resistance box? 2. Okay. Now you can see the galvanometer. Okay. Now I am repeating the data for 2. So you can see that connection is correct. So let's find out. Children, you can see the new reading. The new reading is 47.5 and 52.5. That means while taking the first reading, there was some resistance which was a little bit loose. So the first data which was incorrect, now I am again checking. So the new data I am getting the correct one. It is 47.5 and 52.5. Okay. So for 2 ohm, the data is 47.5 and 52.5. Okay. Now, so we have taken in total 5 readings. We have in total we have 5 readings. What are those 5 readings? You can go through it. I have taken the 5 readings. The first reading is for 2 ohm. The balancing length you can see here. So when I calculated with the formula x equals to r into 100 minus s divided by L. So it is coming 2.21. The second one is coming 2.08. The third one is 2.24 and the fourth one is 2.2 round off and 2.4. So now I will take out the average and then that will be our final reading. Okay. So my average is coming 2.2 ohm. Okay. So this way you can calculate the unknown resistance with the help of Metre Bridge. Okay. Now, while doing the calculation, you will get an idea whether your data is coming wrong or not, because you can see here when I was calculating, I found the four reading were correct. The first reading had very large deviation of 1 ohm. Then again, I checked the last and I got the new reading that was 47.5. So in this way, we can also check whether the data is coming correct or wrong, and the final reading is 2.2. As you know how to write the answer, the first step is aim of the experiment, second is the apparatus required, third is the principle, fourth is the observation table, fifth is the calculation, and then we have the results, and we write down the precautions and what are the sources of error. So I hope today you have understood this experiment. The meter bridge, it is used to calculate the unknown resistance, and we can also calculate further the resistivity with the help of this. How we can do that? We will measure the length of the unknown resistance. This one. This is my unknown resistance. I will take the length of this, and then I will measure the radius of this wire with the help of screw gauge. Then after calculating the length and the area, cross-section area, I will calculate the resistivity. But in the syllabus we have only this form to find the resistance of a given wire or the standard resistor using it. So today we have performed this experiment. I hope you have enjoyed this and you have understood this. Thank you, Chip.